Ever wondered what a real second round tech interview for a DevOps job is actually like? Well, today we're going to tear one apart, piece by piece. We'll see exactly what it takes to show you've got the goods when it really counts.
All right, so you've made it past round one. Nice. But now the heat is really on. This isn't about what you can cram from a textbook, right? No. This is about showing them how your brain works, how you tackle a problem, how you debug, and how you handle those messy, it's 3 a.m. and everything's on fire kind of problems. And the way they do that, by hitting you with real-world scenarios. So let's dive in. We're going to look at the questions, break down the answers, and really get into the thinking that separates someone who's just good from someone who's absolutely great. So here's our game plan. First, we'll check out the candidate's background. Then we'll jump straight into the deep end with some tough Kubernetes challenges. After that, we'll zoom out to the wider DevOps toolkit, talk about production monitoring, and then, wrap it all up by connecting the dots to what the job actually is day to day. All right, let's get into it. First things first, who exactly are we talking about here? Let's set the stage and look at the candidate's profile. Okay, so our candidate is coming in with a pretty solid profile. We're talking about 4.3 years of experience, which is a nice sweet spot. They've got their hands dirty in both AWS and GCP. That's a big plus. They know their way around infrastructure as code with Terraform, and critically, they've worked with Kubernetes on both clouds, so that's EKS and GKE. Throw in the classic monitoring duo Prometheus and Grafana, and yeah, you've got a really strong contender right here. And now for the main event. This is really the core of the whole interview. We're talking a series of practical, hands-on troubleshooting scenarios, all centered around Kubernetes. This is where the rubber meets the road, where the candidate has to prove they can actually do the job. First up, a real classic. You see this pop up. Your Kubernetes API is throwing a 504 gateway timeout. Ugh, it's a super common problem, but man, it can be tricky. This question is so good because it's not just about K8s. It's testing your whole debugging mindset. In a complex system like this, where do you even start? And the candidate's approach is just perfect. It's logical, it's layered. First, you got to confirm the symptom. What is a 504? It just means the backend didn't answer fast enough. Okay, so where do you look? You start at the front door, the ingress. Run a quick kube-cuttle-get and describe to see what it's telling you. If the ingress itself seems fine, well, the problem's probably not there. It's time to move one step up the chain and check out the load balancer. Okay, so the next question switches gears a bit. We're moving away from everything's on fire troubleshooting to something just as important, planned maintenance. You've got to patch the OS on your nodes, but you absolutely cannot take the applications down. So how do you do it? It's a huge test of real-world operational chops. And boom, the candidate comes back with the perfect answer. Kubectl drain. This is the command. It's the clean, professional way to do this. You're basically telling Kubernetes, hey, gently move everything off this node for me. And that little dash ignore daemon sets flag, that's a pro move. It shows you know to leave the critical system pods right where they are. All right, now this next one. This is a biggie. They're asking how you'd upgrade a live EKS cluster. We're talking about a high-stakes operation. One wrong move here, and you could literally take down everything. The interviewer isn't looking for a quick answer. They want to see a careful, step-by-step plan that screams safety first. And the key thing to know, which the candidate hopefully mentions, is that you can't just jump versions. You have to go one by one. So the process is super structured. You start with your pre-flight checks, right? Look for any deprecated APIs that are going to bite you later. Then you upgrade the brains of the operation, the control plane. After that's done, you carefully upgrade your worker nodes, one group at a time. And you're not done yet. You've got to upgrade the add-ons, like core DNS, and then, finally, you validate everything to make sure it all still works. Okay, so we've been deep in the Kubernetes weeds. Now the interview starts to zoom out a little. Let's look at the broader toolkit. The other essential tools that every DevOps engineer is using day in and day out. So they ask about Helm. Pretty much everyone uses Helm to manage their Kubernetes apps. But here's the curveball. What do you do when Helm is the thing that's failing? This is a great question because it tests if you can debug your own tools, not just the code. And the answer shows this really clever two-part strategy. First, you investigate Helm itself. Use Helm status, Helm history, see what Helm thinks is going on. You can even use Helm template to see the YAML it's about to apply, which is awesome for catching syntax errors. Now, if Helm says everything is fine on its end, then step 2 is to look at what it created. You switch back to good old kubectl and start hunting for pod problems like image pullback off. From there, the conversation moved into handling things like TLS certificates, which is a perfect segue into a super important topic. How do you manage all your application's configuration? And the candidate lays out the 3 main ways you do this in Kubernetes. For simple stuff, you can use environment variables. For non-sensitive config files, use config maps. But for anything that needs to be locked down, passwords, API keys, those TLS certs we were talking about, you absolutely have to use Kubernetes secrets. It's all about using the right tool for the right level of security.
All right, so we've built it, we've deployed it, but the job is far from over. Now we get to the part that never, ever sleeps. Monitoring. Your app is out there in the wild. How do you know if it's okay? How do you keep an eye on its health? And here it is, another production is on fire moment. Your pods are just restarting over and over again. You see that dreaded crash loop backoff status. This means your app is basically down. The clock is ticking, and the interviewer wants to see, can you find the problem, and can you find it fast?
The right way to tackle this is like a detective following clues. First, kubectl get pods to confirm what you're seeing, but the real gold is in kubectl describe pod. That's where you'll see the event history and maybe even the smoking gun, something like OM killed, meaning it ran out of memory. If that doesn't give you the answer, your next stop is the application's logs inside the pod. And if you're still stuck, it's time to check your health probes. Maybe you've configured them wrong and they're the ones causing the restarts.
Okay, and for the last part of the interview, there's this really important shift. They move away from the what-if scenarios and get down to the brass tacks of the actual job itself. This is less about your technical knowledge and more about, are you the right person for this team and these challenges? And whoa, this is where you see just how big this role is. It's not just about running some commands. The person who gets this job is going to be the single point of contact for all things Kubernetes. Think about that. That's a ton of responsibility. It means being on call 24/7. It means working side by side with developers. And if that's not enough, there's a huge migration project looming on the horizon, moving everything off of AWS and onto an on-prem cluster. This isn't just a technical job. It requires serious ownership. So what's the big takeaway here? An interview like this, it's not just a quiz. It's a preview of the job itself. They're testing your tech skills, for sure, but they're also testing your mindset, your problem-solving instincts, and frankly, your grit. Can you handle the pressure? Because at the end of the day, the real question isn't just, do you know the commands? It's when things break, and they will break, are you the person we can count on to fix them?